Hello, this is Mrs. Brown, and today we're looking at graphing quadratic functions. So we're going to start with some basic vocabulary. First of all, the standard form of a quadratic function is f of x equals ax squared plus bx plus c. This should look really familiar because we've been practicing this with factoring and all that kind of stuff. Where a is not equal to 0, because of course we have to have a square term if we're going to have a quadratic. The shape of the graph, as we've already been working on, is a parabola. The axis of symmetry, remember, is that vertical line that runs through the vertex. And now we have a formula for it. Ooh. When we're using standard form, we have a formula. So negative b over 2a equals that line, that vertical line. The vertex, if you have a minimum, then a is positive. That means it opens up. If you have a maximum, then a is negative, so it opens down. So again, when we have this in this standard form, if a is positive, it opens up. If a is negative, it opens down. And that helps me to make some decisions about things, okay? And then finally, the y-intercept, when we're in standard form, is just c. Because what would happen is these are going to turn into zeros. And so c, it makes sense that that's going to be the y-intercept, okay? So you can pause this and take down these notes, but you should have this vocabulary. Okay. All right, a couple more vocabulary words. Domain, remember, is the x values, and so these are all real numbers because it can keep going in each direction. The range is the y values. If we have a minimum, it's all, so the graph opens up. All real numbers greater than or equal to that minimum. So I gave you an example. Let's say the vertex is at 0, 2, and it's a graph that opens up. Then the range is y is greater than or equal to 2. If we have a maximum, so it opens down instead. It's all real numbers that are less than or equal to that maximum. So in this example, negative 2, 3, y has to be less than or equal to 3 because the graph's going down. You're not going to have any values up here. And so again, domain and range, these are two words that you should already be familiar with, but here it is in the context of quadratics. Okay, so let's get to actual having to graph. What are these steps we're going to follow? All right. The first thing in order to graph is we are going to find the axis of symmetry. Remember, we now have this lovely little equation to help us when we have it in standard form. So x equals negative b over 2a. So if I'm graphing this, remember that b would be negative 4. So if I'm going to use my axis of symmetry, negative 4 divided by 2 times a, and a is 2. Okay. So negative negative becomes a positive, so that's just 4 divided by 4, which of course is 1. So x equals 1. That's my axis of symmetry. Remember, that's the vertical line that goes through the vertex. Okay, now we're going to find the y-coordinate of the vertex by substituting this in for x. So I'm going to take my y equals 2, and instead of x, 1 squared, minus 4 times 1, minus 6. Okay, so that's going to be 1. 1 squared is 1, times 2 is 2. 4 times 1, minus 6. So y is going to come out to, well, this is negative 2, minus 6 more is negative 8. So that means my vertex, this represents the y-coordinate, this represents the x-coordinate, is going to be 1, negative 8. So I have my first point, which is a really important one for my parabola. Okay. So let's take a look at what the next step would be. So from there, we're going to substitute in more values for x. And remember that the axis of symmetry is the line that things have to be equidistant on the graph on either side. So they're the mirror image of each other. So it actually makes it a lot easier to graph. And then an easy point is always going to be the y-intercept. And so we'll take a look at that in a minute, okay? Remember that I found that my vertex was 1, negative 8. So I'm going to start by graphing 1, negative 8. So 1, -8 is going to go down here, and that's going to be my vertex. Okay. I know that this is going to open up because A is positive. And so I know that this is going to be a graph that opens up. My cat's making an appearance. Okay. Sorry, that threw me off a little bit. So if I take the y-intercept, remember the y-intercept's a really easy point to find because it's just what C is. So C is -6. So actually one of my points is going to be 0 because it's the y-intercept, -6. So when I look at that, what I want to do, let's use a different color, is this is my axis of symmetry, right? So let's just draw my axis of symmetry so I have it there. I know that the y-intercept is 0, -6. So if I go to 0 and -6, this is a point. It's 1 away here, so 1 away here also has to be at -6. So remember, they're balanced. So that helps me to find points. When I'm graphing by hand, I really kind of need like another, like what's the next point in order to get a really good graph going. So I want to do that. So let's just pick another value to substitute. Well, I can either do -1 or I could do 3 would make sense. So let's try -1. So if I substitute in -1, okay, remember -1 squared is -1 times -1 is +1 times 2 is 2. This is like -4 times -1, so that's going to be +4 when we're done, -6. So when you do this, 2 plus 4 is 6, -6 is in fact 0. So my other point is going to be at -1, 0. Now, I should also have a point going one more the other side, so at 3. So let's check that to make sure that it's working, because it should in fact come out to 0 as well. So if I substitute that into my equation, 3 squared is 9 times 2 is 18. And then I end up with -12 -6. 18 minus 12 is 6. Minus 6 more is in fact 0. So that does work out. And then I'm just going to kind of sketch my graph, trying to go through those points, which again, it's never going to be perfect, but the graph of my parabola would look something like that. Let's look at one more example. Okay. All right. So let's say I have this equation and I want to graph it. The first thing I'm going to look, minimum or maximum. Well, A is negative. It's like -1. So this is going to open down. That's good information to have so that when I go to graph it, I know that I should be looking for a parabola that opens down instead of up. So my first step, I'm going to find my axis of symmetry. Remember, x is -b over 2 times A. So in this case, it's -4 over, and this is -1, so 2 times -1. So -4 basically over -2. So it's just going to come out to plain old 2. So my axis of symmetry is 2. So basically there's a vertical line right here. And my vertex is going to lay on that line. To find my vertex, I'm going to take this value and substitute it back in. Okay, let me just go down. So negative, and notice that negative is outside the parentheses because I'm substituting in for x. It's negative whatever this comes out to be. That's one of the places that's really likely for people to make mistakes. So be really, really careful there. Plus, okay, I've got 4 times 2 minus 3. So this is 4 squared made negative. Okay, that's going to be 4 minus 3, so y equals 1. So when x is 2, y is going to be equal to 1. So this is my vertex right here. Okay. Now, the next point, okay, I want to look at is maybe the y-intercept, because again, that one's really easy. So if I look at my equation, my y-intercept is what c is, so c is -3. So if I take my y-intercept, that's just going to be 0, -3. Okay, so if I go to 0 and -3, that's going to be a point. Now, notice it's 1, 2 away, so 1, 2 away is also going to be at -3. So that would be 5. No, 4. 1, 3, 4. Sorry, I can't see it from this angle very well. So that's going to be at 4. -3 is going to be another point. And I could check that if I was unsure. So what I want to do is substitute in 1 and see what happens, because that will give me a good idea. And I'm going to switch colors so it's easier to see where I am. So if, let's say, we have 1 instead. Okay, that's going to be 1 squared is 1 made negative, plus y times 4 times 1 is 4, minus 3. -1 plus 4 is 3, minus 3 is going to be 0. So when x is 1, y is going to be 0. Okay. So again, if I'm looking at my graph, when x is 1, y is 0, which means that when x is 3, it also has to be 0 in order to be symmetrical. Oops, I missed that point a little bit. But my graph will look something like that. And obviously that's like, I went way too far on that one. Sorry about that. All right. I hope this helps, and I will talk to you soon. Have a great day.